All right, so we did a little bit of moving around different sections, but it was all to do with this. We are going to analyze graphs of quadratic functions. So we're going to find a vertex and axis of symmetry, and minimum and maximum values of a quadratic. So that's why I bothered learning about minimums and maximums. We're going to graph the quadratic functions, and we are going to use an applied problem to solve for a maximum or a minimum. So we did one of those earlier. We did it with graphing. This time we can do it without a graph. Okay. So one of the things that we know, let me put it over here. So we've seen this several times. If I had the graph of x squared, this point here at 0, 0 is what we call a vertex. So the vertex is this point that is where you change in a quadratic function from decreasing to increasing or increasing to decreasing. So it is a maximum or it's a minimum point. So to the right is a graph of x squared, but what we see here is that I had shifted it to the right by 2 units, and then I shifted up by 1. So recalling what we have learned about quadratic equations, if I want to shift right, that means I have to subtract 2 from my x. And if I want to shift up by a unit, that means I have to add 1 to the whole function. So what we're going to do is we're going to take y equals x squared. Well, now it's going to be x minus 2 squared. So we can get that shift to the right. And then we add 1 to the outside to make it shift up. So this is still a quadratic equation. But it's in what we call vertex form. Okay. So that's why we talked about shifts, is so we can kind of see where these shifts are coming from. That vertex form is really talking about shifting that vertex. All right, so there's going to be other parts of it, but those are sort of the main ones for right now. So vertex form for a quadratic equation. So anytime we have a quadratic equation, sort of the go-to label for your vertex is this HK. Like I said, vertex is the minimum or maximum, actually location, sorry, let me fix that. That's basically the location of the minimum or maximum value. Of a quadratic in this case. And we're mostly talking about the graph of the parabola. So it's more like where we have that. So when we have vertex form, so remember that if I'm shifting to the right, that means I have to subtract the h. So we get x minus h. And then, but to go up, that has to be a positive, so I have to add the k. So vertex form is going to be y equals a x minus h squared plus k. Okay. So this is sort of more officially altogether. So the graph of a quadratic function is always called a parabola. The point hk at which the graph turns is called its vertex. The minimum and maximum value of x occurs at the vertex. Of f of x occurs at the vertex. Each graph has a line x equals h, which we call the axis of symmetry. So the reason we call it the axis of symmetry is because, as you see here, this is like I was to fold the graph in half at that point, it looks the same on both sides. So it's mirror image over that vertex or over the axis of symmetry. That is a mirror image over the axis of symmetry. You can take taking a lot of biology classes. One of the things you hear a lot about is symmetry. Okay. So just so we can see this again here. So for this first one, we see we have a vertex at -3, -2. So remember, your generic quadratic or parabola is just going to be x squared. So the new one I'm going to make here, if I was to rewrite it, what happened here is that I had to go backwards 3 units. So I had to add 3. And then I had to go down 2 units. So I had to subtract 2. So the equation is going to be, so this 2 part we don't know about, but there's some sort of a here. We're not sure what it is, but what's important is this vertex is going to be at x plus 3 squared root 2. So that gets that vertex at -3, -2. Same thing here. I have my vertex at 1, 3. So that means I have to subtract 1 to make the vertex move to the right, and then add 3 to make it move up. So that's why we get x -1, and then we get squared, and then plus 3. All right, so another thing to point out here, like I said, this is going to be that part that we call the A. Here A is positive, we see the graph is opening up. Here when it's negative, so if you remember when we had a negative out front, we called this, what we said was a reflection over the y-axis or x-axis. It means that my graph is going to change from opening up to opening down. So A positive, parabola opens up. Or sorry, yes, opens up. If A is negative, the parabola should open down. So some of the main points here to look for when we're doing a lot of this graphing and trying to figure out what's going on with the equation or identify, equations that go with our graphs. All right. So this one here, I want you to tell me what the vertex is. Is the graph opening up or opening down? Because that's going to tell you what A is. And then you're going to write an equation for the parabola in vertex form, and you're going to assume that A is -1 or +1, meaning this is vertex form of an equation, that A is either it's going to look like this, because A is going to be +1, or it's going to look like this because A is a -1. You just have to tell me is it positive or negative, because is it opening up or is it opening down? And the same for 14. So take a minute, work on those, and then we'll come back and finish that part out. Okay, so vertex. Looks like it's right here. So that's -2, -4. So this is probably -3. So x is -3. And then, like I said, 0, -1. So this is, or -2. This is probably -1. So it's a point -3, -1. And then just something to point out here, once again, let's use a different color. Your homework does ask you for axis of symmetry. The axis of symmetry has to go through your x coordinate, so it's just going to be x is -3. That's all axis of symmetry is just your x coordinate. Because if I just say x and set to my x coordinate, it's going to make that vertical line that goes right through the graph. The next part was, is it open up or open down? Opens up, which means that if I'm dealing with A is going to be positive. So vertex form looks like f of x is equal to x minus h plus k. So just as a reminder here, your point here, that is your hk. So what we have here is that right off to the side here, if that was my point, h is going to be -3, k is going to be -1. Because it opens up, a has a choice of being a +1 or a -1. A will have to be a +1. So we were to fill this out, we're going to have 1 h minus -3, or you could have said, hey, I have to shift it back 3 points, it has to be a +3. Got my squared, and then the k is a negative, so it's going to be -1. So you're going to have x plus 3 squared -1. Or like I said, you could just run, hey, it has to shift to the left. That means I have to add the 3. It has to shift down 1. I have to subtract the 1. So that is your equation in quadratic form, or sorry, vertex form. So 7, vertex is here. So that is a point where x is 5. Let me see where my 1, 2, 3. Y is -3. So there's a space here got missed, but the graph is opening down now. Which means that when we have A is going to be negative because we need it to reflect down. So y equals a x minus h squared plus k. So in this case, we'd see that a, because the parabola is opening down and a has to be +1 or -1, in this case, a is going to be -1. H is going to be 5, because this is always hk, and k is going to be -3. So in this case, we're going to have y equals -1 h minus 5 squared minus 3. I'm going to write that in function notation, so it should actually be this. Negative x minus 5 squared minus 3. So if you had to find roots of this, all you'd have to do is expand it. So if I expand this, I'd end up, that's a negative out there, x minus 5, x minus 5 minus 3. So it's just rewriting it. We're going to get x squared minus, minus 10x plus 25 minus 3 out here. This would be minus x squared plus 10x minus 28. So these are both the same equation here. Just wanted to point out that you can expand this. You can get back to that form where we have a squared plus b, a squared plus bx plus c. So this is vertex form. And then this is general form. Or standard form. I'm trying to remember which one your book said.